Okay, here I have drawn the inverted cone, which represents the situation. So we have this inverted cone with the dimensions 12 feet at the top. That is, the diameter of the cone is 12 feet. And we are also given the depth of the cone, which is 24 feet. So basically, this 24 feet represents the height of the cone. And we are also told that water flows into the cone at a rate of 8 feet cube per minute. That is, we are given this information dV over dt. That is, the rate of change of volume of water is 8 feet cube per minute. And we have to find the rate at which the water is rising in the tank. That is, we have to determine dH over dt. This represents the rate of change of height for different situations, like when the height is 1 foot, 10 feet, and 23 feet. So let's see how to determine this rate of change of water level at a point time. So first, I'm going to find the relation between the radius and height of the cone. If you look at this diagram, this OA is the radius of the cone, and OB represents the height of the cone. The height of the cone is 24 feet, and we also have two triangles. That is, OAB is considered as one triangle, and also consider the another triangle, that is, we can write down this as CDB. So these are the two triangles which we have to consider, and we have the right angle at O. This is O is right angle, as well as at the vertex C of this triangle. This is a right angle, and this means these two triangles are similar according to AA similarity. That is, according to the angle similarity, these two triangles are similar, and this means the ratio of the corresponding sides are proportional. So we can write OA divided by CD, and this equals OB, which is the height of the bigger triangle, and divided by the height of the smaller triangle is CB. Now let's replace the values. OA equals 6, which is the radius of the bigger cone, and then CD represents the radius at a point time, that is R, and this equals OB is the height. You can see that it is 24, and this divided by CB is H. So let's rewrite this. I'm going to multiply both sides by R now, so therefore this becomes 6 equals R times of 24 by H. Now let me divide by 24, that is 6 divided by 24, and this equals R by H. So we can simplify this. That is, this implies R by H equals 1/4. So therefore I can write down R equals 1/4 of H. I just multiply by H on both sides. So this is the relation between the radius and height of the cone. Now I write the volume of the cone, which is given by the formula. The volume of the cone, let's say it is V, and this equals 1 by 3 times of pi R squared H. So this is the standard formula to calculate the volume of a cone. Now since we know that R equals 1/4 H, we can replace it into this volume formula. So therefore this becomes 1/3 pi. R is 1/4 H, and this is quantity cube times H. Let's get this simplified. So this equals 1/3 pi. Cube of 1/4 is 1 by 4 cube times cube of H is H cube. We then have H. So let's simplify this. We have pi in the numerator, and H cube times H is H power 4, and this divided by 3 times of 4 cube. So 4 cube is 64. So it is basically 3 times of 64. So this gives pi H power 4 divided by 64 times 3. and this equals 192. So we get the expressions for volume after replacing the radius. That is, we now get this expression in terms of height. So which is volume equals pi h power 4 divided by 192. I'm sorry, I have actually cubed it, but this is r squared. We have to put squared here, not cube. So I'm going to change this cube to square, and we can redo starting from here. I'm going to remove everything here. So let's continue. So therefore, this will become 1/3 pi times of h squared divided by 4 squared times h. So this gives, we will have pi times of h squared times h is h cube divided by 3 times of 4 squared, which is 3 times of 16, and this equals 48. So this is the expression for volume in terms of height. Okay, so now that we have determined the volume expression in terms of h, we can find the derivative of the volume expression with respect to time. So we are going to derivate this on both sides with respect to time. So therefore, I'm going to get dv over dt, and this equals, I can factor out the constant pi over 48, and then I have to find the derivative of h cube. Derivative of h cube with respect to time is 3h squared. When you apply the power rule to find the derivative of h cube, and then apply the chain rule to find the derivative of h with respect to time, which is dh over dt. So this expression gives the expression dh over dt. So we now solve for dh over dt from this expression. So this means, first let me simplify the right side. So I can write down the numerator as this is 3 pi h squared. This is 3 pi h squared divided by 48. In fact, we can reduce this, 3 can be divided by 48. So this gives 1 by 16, or I can write down this as pi h squared divided by 16 times of dh over dt. And on the left side, we have dv over dt. Now we just want only this term on the one of the side, either on the right or on the left. So let's multiply by the factor 16 and divide by the numerator, that is pi h square. So therefore we can write down the dh over dt, and this equals 16 divided by pi h squared. This gets multiplied with this expression on the left, that is dv over dt. So we now solve for dh over dt. We can substitute the different heights, that is 1 foot, 10 foot, and 23 feet. So first I'm going to plug in h equals 1 foot into this dh over dt. This basically gives us the rate at which the water level is rising. So we can write down this as dh over dt when h equals 1, and this equals 16 divided by pi times of 1 square. And then we replace dv over dt by 8. So therefore this is 16 times of 8 divided by 16 times of 8 divided by pi times 1 squared is 1, so it is pi. We plug this into the calculator, and we approximately get 40.74. This is 40.74. This is 4. The unit should be in feet per minute. This is the rate at which the water level is rising when height equals 1 foot, or when the depth is 1 foot. We now plug in h equals 10 feet into the same expression and calculate the dh over dt. So h equals 10 feet, and this implies dh over dt when h equal to 10. We plug it into the expression. So it becomes 16 by pi times of h squared. 16 by pi times of h is 10. So it becomes 10 squared, and then dv by dt is 8. And this equals 16 times 8 divided by 10 squared is 100. So it becomes 100 pi. Once again, we plug this into the calculator, and when we do that, approximately we get 0.407, and this is in feet per minute. Now let's plug in h equals 23 feet into the dh over dt. So we put h equals 23 feet into dh by dt. So therefore it becomes dh by dt when h equals 23, and this equals 16 over pi times of 23 squared times 8. So we can plug this into the calculator, and when we do that, we get approximately 0.0770, and this also in feet per minute. So we have determined that rate at which the water level rises for different depths of the water, that is for 1 foot, 10 feet, as well as for 23 feet.